Awesome.
Sick. Well, Richard, thank you so much for joining us. I'm excited about this. We've been chatting, both over Zoom and on Twitter for quite a while about your cool startup. And I think that both people who showed up today and those who watch after the fact will be excited to kind of learn about some of the interesting things you're hacking together with this new space at LLM. So I'll let you take the stage. And yeah, thanks for joining us.
Awesome. Yeah, I have a few different presentations that I can give. Maybe like one thing that we can talk about is the next generation of AI platforms. Like what does the next generation of Hugging Face look like, for example? I can also talk a little bit about LLMs and why I think it's such a paradigm shift in AI as well. I don't know, what does everyone think? What would you prefer to hear about?
I mean, the latter sounds more like your sort of sweeping vision, right, of where all this is going. So maybe that is a more exciting place to start. But I think whatever you're more passionate to present is fine.
Cool. Yeah. So about LLMs and why they represent such a breakthrough?
Yeah, I think so.
Okay, cool. Let me just get this presentation up. We can even like dive into the other one as well at some point. I think the LLMs is probably about a 10-minute presentation. And then I've like a longer one about what the different platforms look like as well. I think we have a full hour. So
yeah, sounds great.
It's up to you. Okay, fantastic. Okay, so LLMs as a paradigm shift. I guess everyone here is from like computation background. Does everyone have a lot of experience about AI, or should I assume not?
I think reasonable amount, yeah, but various. Like David's got an electrical engineering degree. Alex has a physics and math double major. Brennan's a computer scientist. Holmes is running a software engineering company. I don't know what your education was in. So, kind of all over the place, but everybody's got computer science in common for sure.
Okay, awesome. Yeah, that sounds great. So my background's actually in mechanical engineering. I did a PhD in like fluid dynamics and heat transfer. So something completely different. I come from a little bit outside a computer science degree. I did do some like computer engineering and stuff, but came into this from a non-standard direction, I guess. So yeah, definitely resonate a lot with the electrical and electronic engineers. So yeah, similar backgrounds. Let me share my screen and we can dive in. Okay, so can you see my screen?
Yes, looks great.
Okay, sweet. Okay, so I come from like the place where I work the most at the moment, I guess, is like the decentralized web, like DWeb, or I also like work with a lot of different like crypto and Web3 companies. So a lot of the time, I feel like I need to give the AI point of view and just like tell people what's going on in the world of LLMs and why I think it's such a paradigm shift compared to the way that we used to do AI. And so this is the presentation I usually give to them, just about why LLMs are such a big difference compared to what we're used to in AI. And as I mentioned, after that, we can like dive into what I think the next generation of platforms will look like. And by platforms, I mean things like, Hugging Face, for example. This is a platform for doing AI, which has been around for a while and is basically a hub for like model weights and data sets and code and stuff like that. And I think we're going to see a different generation of platforms as a result of this different generation of AI as well. So after we go through this first presentation, we can even dive into that depending on what people want, or we can like discuss LLMs in general, do Q&A and stuff. So really whatever everyone here wants. Okay, so yeah, again, this is like maybe targeted at crypto a little bit, but I think what everyone's talking about LLMs, right? And a lot of people talk about training LLMs rather than what you can build on top of them, and lots of people don't understand, I think, why LLMs represent such a paradigm shift. We're starting to see a lot of different blog posts come out about LLMs as a platform and LLMs as a new type of operating system. And I think that really gets to the core of why LLMs are so important. And that's what I'm going to dive into a bit in this presentation. So prompt engineering, I was like super critical of prompt engineering when I first heard the term. This is what a lot of people think of prompt engineering as in the top left. So, maybe talking to Stable Diffusion and trying to get it to generate an image, and adding a bunch of different natural language afterwards, saying things like, ultra HD, 4K, just trying to get the output that you want from this LLM. So this is what a lot of people think of prompt engineering as, and a lot of people talk about how it's going to disappear as a thing. I take a slightly different view, I guess. I think there are certain aspects of prompt engineering that are temporary, like, for example, adding like way too much natural language afterwards to get exactly what you want. I think that will disappear. But I think what's not going to disappear is this idea of a prompt as a program. So we have this kind of like limited amount of natural language to elicit the type of behavior that we want from an LLM. And you can use this prompt to include many different things. You can even, include data in the prompt to personalize it towards a certain behavior. You can, kind of demonstrate how to do reasoning and all these sorts of things. And I think this is the part of prompt engineering that isn't going to go away. So one of the big breakthroughs, I'm going to talk about 3 today, and the first one is in context learning. So why is this such a paradigm shift? For those of you that don't know, there's an example of in context learning on the right, and so in the box with the blue input, the blue input label, this is what you actually put in the prompt, and then the green label is like what is output by the model itself. And so what a lot of people will be used to is just putting a question in the prompt and then getting an answer from the model. But what people realized is that we can actually feed in data into the input prompt. So we give an example of a question and an answer in the input prompt, and then we ask the question. And hopefully the language model is then going to condition the output on the examples that we've given us in terms of full Q&A, which will actually change the answer that it gives to the question that you ask. So in this case, it actually gets it wrong, but usually this really does help the model to understand the output that you want just by giving it maybe one example of Q&A or even like 5 or 10 or whatever. Yeah, and this is very different to the way that we used to feed data to train models. So like a lot of people will be familiar with fine tuning, for example, where you take a data set of inputs and outputs, you pass it into the model, and you update the weights of the model. That's the old way of feeding data into models. But this new way, in context learning, we're giving it data in the form of the input prompt. It's learning to do things on the fly, and all of this happens without any weight updates. This was like a really big discovery that happened just when models became large enough. And if you read a lot of the literature, there's a few studies like trying to explore where does this ability of in-context learning come from. But in general, it's not well known where it comes from. It's just this thing that we discovered as we trained larger and larger models. And so yeah, the model can follow a few examples of a given task and then generate the solution. So even if you give it new types of data that it hasn't seen during training, it will still learn on the fly without updating any weights of the model itself. It's a very different mode to fine tuning. It behaves very, very differently. Like, for example, people have found that you require fewer samples of data to get good performance on a new question. And yeah, this unlocks a ton of ability that we're still exploring. So, for example, there's a really good paper that I've linked here that compares the performance of local language models, which are personalized through in-context learning. So, in other words, no training. And what people have found is that it's actually competitive with federated learning. So, what do you really want if you're a user, say, trying to perform some task on a laptop? What people used to do was, because we needed a lot of data to get some sort of personalization, people would have to pool data sets among lots of different users. And because a lot of the time that's personal data, it meant that yeah, we had to like basically share these details among lots of users to get this personalized behavior through federated learning. And what people have found now is that rather than like pooling a lot of personal data in a privacy-centric way using federated learning, what you can actually do is deploy a language model locally. You can pass personal data as context to the language model, and you get like similar performance to the personalization that you would achieve using federated learning. So in other words, we're personalizing the behavior of these language models without sharing any data among users, which means that we get better privacy. So federated learning achieves pretty good privacy, but you're still passing the gradients between different users. and therefore it's not perfectly private. But if we deploy a local language model locally, we don't need to pass any data among users, and we still achieve like pretty good personalization, which is as good as federated learning. And so this like really blows open a whole bunch of stuff and opens up tons of use cases. What if we can just deploy a bunch of language models locally, maybe on every single person's laptop, achieve personalization through in-context learning? What does that mean for federated learning? Do we need it anymore? I'm sure we do a little bit, but it's definitely a really good option to have. And so the significance of this breakthrough with large language models is that personalization previously needed a full training set. And if you didn't have a full training set for a single user, you had to create this full training set amongst a group of users. And now what we can do is just have local language models with just a few in-context demonstrations. So that's one really big breakthrough of language models that represents a paradigm shift from my point of view. So that's the first breakthrough, I think, in context learning, this thing that we discovered. Another one that we've discovered is generalization to unseen tasks. So anyone who's trained models will be familiar with the fact that the training data set that you work with is really important. So if you train on a certain data set and then you test on some sort of sample that is outside the distribution of the original training set, then it's not gonna perform as well, right? And what people have discovered is that once we reach a certain size of model, it performs much better with data that is outside the distribution of the training set. This is really significant because it's just really important for deploying language models into production. Usually when you deploy a language model into production, the user is always going to come up with something that is outside the distribution of the original training set. And this is a place where traditional machine learning methods really struggled. But now we find that large language models just perform much better with this out of distribution data. And that's probably why people get so much utility out of, say, ChatGPT, for example, because you feel like you can ask it really anything, stuff that definitely wasn't in the training set before, and it still performs pretty well. So this is like a really big breakthrough. And the place that people think that this comes from is from the instruction tuning of the large language model. So I'm not sure how familiar everyone is of these LLMs and how you train them. You do this unsupervised learning on, all of the web's data, essentially, just trying to predict the next word. That's like the first phase, is this unsupervised phase. But then what a lot of these model providers do is they do some sort of instruction tuning. So there's a few different ways of doing this. You can do instruction tuning using supervised learning, or you can do instruction tuning using like reinforcement learning, which is sometimes called reinforcement learning from human feedback. And what people find is that by doing this instruction tuning on a certain set of instructions and a certain size of model, it just like generalizes really well to instructions that it hasn't seen before. And so this is kind of the source that people think that this comes from. And it's really a big breakthrough as well, because it just means that these large language models have better generalization. So that's like the second big significant change from the previous generation of AI. And then the last one is this ability to do complex reasoning. And so, yeah, chain of thought. I'm not sure if people have heard about it before. It's this prompt engineering technique, which is shown on the right-hand side. So again, you'll see the question answer that we saw in a previous slide, which is called like the standard prompting in this case. So you'll notice that when we provide this example in the input prompt, when we do standard prompting, we don't really show it like the procedure for answering that question. We're just saying the answer is 11. So we're not showing it like the process, the reasoning that it needs to go through to generate this answer. What we find in this case is that if we give it some sort of sample in the input prompt, and when we provide the answer in this sample, if we like kind of do it step by step, and we give it this reasoning procedure and show it the process for figuring out the answer. So rather than just saying the answer is 11, we say, okay, well, Roger, he started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, 5 plus 6 equals 11, therefore the answer is 11. If we show it this process, it will then use that process when it's answering the question that it doesn't have an answer to, and it performs much better. So this like method of prompting is called chain of thought prompting. It's like a type of reasoning. And if we show it how to do this reasoning in the input prompt, often it does this for like, a question that it hasn't seen the answer to. So people have been like studying this, and they realize that this ability really only emerges in large models. above a certain parameter count. And what people are starting to realize is that this may come from doing some sort of training on code rather than text. So this was a really big surprise in language models. People used to, just train on text because it's like the task that we wanted to perform is usually like language modeling or something. But what people find is that when you train on code, it still performs really well on text, and this ability to do reasoning kind of emerges, right? And so people think that reasoning is contained in code data. And so by training it on code, we magically get this like ability to do reasoning. One of the sources of evidence for this, for example, is that I think the original GPT-3, like 3.3.0, it didn't have this ability to do reasoning. And that's because it wasn't trained on code. But by the time we got to like GPT 3.5 and GPT-4, because it was trained on code, this ability to do chain of thought, this ability to do complex reasoning kind of emerged from that fact. And so like reasoning is such an important thing to have in a language model, right? And people are starting to think of LLMs as reasoning engines. And this is really the part that opens up the possibility of building a whole new computing platform on top. And people are starting to talk about using LLMs as a new type of operating system. And it kind of comes from this ability to do reasoning. And there's a really good series of blog posts. I've linked it here. At the bottom, it talks about like where these abilities emerge from GPT, and it tracks kind of the lineage of these different GPT models. I'd really recommend. There's about like 2 or 3 different blogs written on Notion that talk about these things. So they're the 3 really big breakthroughs that I think represent a paradigm shift with LLMs. So just to summarize, LLMs can do personalization on the fly with very few data samples or demonstrations. They can do more general tasks compared to the previous generation of AI, and they can also like do reasoning, which is really what allows us to build this new type of computing platform. And so I think this is what it means for LLMs to be a new computing platform, and this is the reason why people are talking about building a whole operating system on top of LLMs. Okay, so yeah, I haven't linked any different links to the different operating systems that people think can be built on top of LLMs, but I wonder at this point, yeah, maybe I can pause for questions. Maybe we can talk about these different breakthroughs, and then maybe we can dive into the presentation on platforms as well. And just one more note, I guess. So like I got into machine learning in like 2017, and I actually started a startup, an AI startup, which was on human pose estimation for motion analysis of athletes. And like one of my learnings from setting up the startup was just how hard it is to build a machine learning app. So for example, you have to like basically build a full stack for an AI app. And I usually divide these into 4 different stages. The first stage is data acquisition. So we spent a really long time collecting a training data set that we could use to train the model. That's like the first stage, the data acquisition stage, and that requires a very particular set of skills. Ideally, you need a domain expert who knows the data really well. So in our case, this was like motion data. We collected it using a motion capture system, and that's like completely separate to like any sort of like AI skill set or anything like that. That's the first stage. Then the second stage is you want to develop a model. And this is what you need a data scientist for. You need someone who's going to like play around with neural network architectures, add a few different layers. So that was like, that's a completely different skill set that you need. The third stage then is like actually deploying that model. So not just prototyping, but deploying it on the cloud. And the skill set that you need for that is completely different. Again, you need to know how to use cloud, maybe like AWS. And this is what we usually put in the realms of like a machine learning ops engineer. That's the third stage. And then the fourth stage is that we need some sort of app to be built, a UI that people can interact with the deployed model through. And this is what usually needs like a full stack dev or like a designer for. And so you can imagine like trying to build an AI startup and having to do all 4 of these different stages. You have to hire for these different skill sets. You as a founder, you need to upskill on all 4 of these very different different skills, and it can take a really long time. So it was like 2 years before we really had anything that we could put in front of users, just because we had to do the data acquisition, we had to develop the model, we had to deploy it, and we had to build the UI. And so that's why I think LLMs have really changed things, because now you see people building these proof of concepts in like a few days. And the reason that they can do that is because all they have to focus on is like building the app itself. You don't need to worry about like developing the model to start, because you can just build on top of a large language model provider like OpenAI. You don't have to worry about data as much, because maybe you can do in-context learning with a few different samples, and you don't have to worry about like the compute infrastructure or getting set up with AWS. So it's just much, much quicker these days to be able to build this app. And that's why we see so many cool AI apps being built. And of course, this doesn't mean that all of the other stages become irrelevant. It just means that you can like do this rapid prototyping stage. You can build an app that you can like get in front of users really, really quickly. And then if the users like it, if it's successful, if you get some sort of traction, that's when you can potentially do all of the other things that we would have done before, like acquire your own data set. Maybe you want to deploy in your own infrastructure. Maybe you want to develop your own language model. All of those things can still be done, but it shouldn't be the first thing before you get some sort of like traction and adoption from users. So that's why I think LLMs are such a big paradigm shift, because we've like unlocked these like breakthroughs that were really unexpected and just kind of emerged with these large language models. And now that's led to this this like creator economy that we have now, where people can build apps in much quicker time, much shorter than 2 years before you can get it in front of users. And so yeah, I'd love to get any questions from people here, like pushback, any of that sort of stuff. And then after that, maybe we can dive into what the next generation of platforms for these LLM apps looks like.
Do you know if anybody's tried to train LLMs on the results of SAT solvers or theorem provers or other, like, I'm thinking of classical kind of pre-machine learning techniques for symbolic reasoning, right? There's a lot of these calculational techniques for doing symbolic reasoning. I would wonder how training an LLM on something that's built from the ground up just to do logic and nothing else compares to training it on, say, code, pulled from GitHub.
This is a really good question. I think I've seen a few things recently, like tweets, people basically saying that what we really need to train on is something that has this symbolic reasoning, this sort of logic. And code kind of is a stand-in for that, because we have this like reasoning, this logic within code, and that's the reason that we get these reasoning abilities. And I've started to see people talking about training on like mathematical programming, this sort of symbolic reasoning. I haven't seen any results of that yet, but I'm pretty sure I've seen people talking about it. And I think that's a really promising direction for improving the reasoning of these large language models even further.
So my question was actually an inversion of what Max was going to ask. Are you aware of like guess and check architectures that do the opposite, that take some sort of naive LLM output and then apply some sort of semantic, turn it into a predicate magic to it, and then use that to verify the syllogisms, etc.?
Interesting. Yeah, no, I haven't heard of that. But what it reminds me of is like the difference between, say, including this logic during the training phase, which is what we do when we like fine tune on code, or maybe even like some sort of mathematical programming in future. That's one option, to like kind of include this reasoning. And then the alternative is to include this logic or reasoning after the model has already been trained. And this is kind of like what happens with, you see people doing it in LangChain, for example. The human can kind of insert this logic in terms of the like chain of prompts or the logic that is built on top of these API calls. I guess something like that is what you mean?
So it sounds like you're saying like inserting it in the context rather than in some sort of deterministic architecture outside of the stochastic stuff. But yeah, pretty I guess. Yeah,
I think like the important thing is that the logic gets inserted somewhere. So whether that's during the fine-tuning stage, or in the kind of app that's built on top of the language model. I think it's super important to like include it somewhere. And there's like different ways of doing that, and a lot of it is like really unknown what the best way to do it is, just because all of this stuff is so new.
Could you give us some sort of overview on which tasks zero-shot generalization is best and worst at right now?
Which tasks it's best at in zero shot? I think that it's a good question. Have I seen any studies to show which zero shot is good at? There's like a bunch of different data sets that are coming out now that basically test this reasoning ability. And a lot of it is super new. I haven't dived into any of these reasoning data sets a huge amount. Like a lot of the ones you've probably seen, like for example, just doing the SATs or some of these different exams. And we a lot of the time we see that LLMs have aced these exams and stuff. I can be a little bit skeptical of how much of that data is leaked and stuff like that. But these are all the sorts of benchmarks that I think people are starting to test it on. And I guess in general, like what is the limit? I think, like from what I've seen, and I haven't dived into this in too much detail, what LLMs are good at is doing reasoning in a manner that has been kind of seen in the data set. So doing like reasoning operations that are present somewhere, say within the code or wherever it's trained, or maybe like on the data on the web. What they still can't do is like some sort of reasoning that they haven't seen anywhere within code or in internet data. And so I think like Francois Chalet, he came up with a really interesting benchmark. It's almost like an IQ test that asks you to like reason over different patterns and all that sort of stuff. And he came up with a few different examples of reasoning that you can be pretty sure that it's never seen before, and we still find that LLMs struggle there. And so probably the types of reasoning that we see in code, for example, an LLM can kind of learn how to do that method of reasoning, even if the details of that reasoning are slightly different. But in terms of like types of reasoning that you've never seen before, where a smart human would be able to figure it out, the LLMs still can't do that. They're still kind of learning from the data in some sense. While they're still generalizing, they can only do like reasoning behaviors that they have experience of before. So I don't know if that answers your question.
I found that some of the things I have, ChatGPT 4, and I found that some of the things it's really good at, or that I find it useful for, are tasks that have the flavor of translation, but are much more complicated. And an example would be, I wrote a proof in English. I knew it was correct, and then I had to implement it in a theorem prover. So, but it was an obscure prover called ACL2 that's like not used a lot on the internet, so there wasn't necessarily a lot in the training corpus. And so I first just said, please rewrite this in ACL2, and it gave me garbage. So then I said, line by line, translate each line of my proof into a line in ACL2. Here are 5 examples. And I gave 5 examples, and it did it almost perfectly. And the resulting proof, I had to fix like 2 minor things, but it was nearly perfect. But that was essentially a translational task, right? It was like translating from English to Russian, but it was translating from English to this formal syntax after having been given examples, which also makes sense given that that's where transformers come from, is literally language translation, right?
Yeah, and I think that's like a lot of the symbolic reasoning that you do is like really interesting as well. Like if we're trying to do a proof, a lot of the time, if you're doing a proof, like you probably learned how to do a proof for exams sometimes. That is a type of reasoning that is like kind of well established and kind of procedural in a way. Like, is it really reasoning? I don't even know what the definition of reasoning is anymore. People overload the term so much, but that type of reasoning where say you need to do some sort of integration over an equation or something, or some type of proof that the procedure is well known. These are the sorts of things that an LLM can do because it's seen that approach before, even if it hasn't seen those exact numbers. But there's like a type of reasoning that humans do as well, where you're sitting down in front of an IQ test for the first time. You've never seen this example, before, and it needs a completely new way of reasoning. You kind of need this like open-ended discovery of a new way to reason. That's like really what LLMs aren't good at.
So you had sort of a hint of something on a slide that you didn't talk about, which was the integration with some of the Web3 stuff. And I think that's maybe where people in this group would be slightly more skeptical. But in the interest of fairness, I'm curious to know what the pitch is for that aspect.
Yeah, that's why I tried to brush over it a little bit. I know that like people can be like skeptical of Web3 and crypto, and I am too. Like I actually get more skeptical by the day, I think, with Web3, and I think what I really believe in is like decentralization. That's what the motivation is for me. And hopefully I've started using, instead of saying like Web3 AI, I've started saying decentralized AI, because I think that's like a principle that people can get behind. And like hopefully people agree with me when I say that, my ideal is to not have, a few big model providers that are capturing all of the data and using that data to train like a handful of really intelligent systems, right? That's where my main motivation comes from for exploring crypto. But I think like what I'm most passionate about is just decentralizing AI in general. And I'm kind of agnostic about how that works. I think there's like a bunch of different approaches. People have explored like the semantic web, like the original Web3 and stuff, which was by Tim Berners-Lee. And like there, the idea was to basically separate the data layer from the app layer. That's really what it's all about. At the moment, Google is both the data layer and the app layer, and that gives them a ton of like power or whatever. And so what Tim Berners-Lee wanted to do was to have these apps doing like similar stuff, but they're reading from this like independent data layer, and then the data can be kind of like shared amongst different apps and stuff. And his idea was that this would like reduce this problem that we have where say Google or Facebook are using our data against us. So that's like one method of decentralization is like DWeb, as people call it, or like the semantic web or whatever. I think there's other methods of decentralization, like even open source AI in general is a way of decentralizing things. It's by putting these like open source models in the hands of a lot of people, which has benefits. Like, for example, you get more eyes on it, so that if there's some sort of vulnerability, hopefully people are going to discover it in open source better. And then also like you can just have this like long tail of experiments on top of open source models, which is the reason that like Stable Diffusion won against DALL-E, because DALL-E it's like run by a single company, so they're going to like push it in a single or like a few directions. Whereas when you put Stable Diffusion in the hands of many people, you get all of these crazy experiments, and people are going to try run it on laptops, and people are going to try run it on phones, and people are going to try integrate it with all types of software. So I think that's like another method of decentralization. Another one that I think is like a decentralized approach is like private AI, or like privacy preserving machine learning, like using OpenMinds, for example, because the idea there is to like keep the data at the edge, and do some sort of personalization using federated learning traditionally, so that these like centralized apps don't have a bunch of power, and they don't get to like look into your data, which doesn't have any privacy at all. So I would consider that another approach to decentralized AI. Even in like mainstream AI at the moment, we're starting to see decentralization, or maybe like distributed AI, where we have these like multi-agent systems, and it kind of goes against like what say OpenAI think, in that they're trying to build this like single artificial intelligence system that maybe knows everything, right? But I think like what I definitely lean towards is this idea of having like many AIs, many different agents. Some of the different ones are specialized or fine-tuned towards certain use cases, and overall this like collective intelligence of distributed AIs, I think in my opinion is going to like be more powerful than a single entity which knows everything. I just don't think that's possible. I think there's like limits or whatever. So these are all like different approaches to decentralization we see like outside of the crypto Web3 space. And then of course there's like interesting technologies in crypto Web3 amongst the scams. There is some useful stuff there, that and it's like well funded as well, I guess, is the thing. So like that's why there's so much research going on in decentralization there. Some of the things that I think are interesting in crypto are this idea of using so I know everyone hates the word NFTs, but people are starting to create like data NFTs, or like say model NFTs, not to create these like, you know, Bored Ape Yacht Club or CryptoPunks or anything, but basically just as this like representation of ownership of some sort of asset, whether it's like a data set or a model. And what does ownership mean? It basically means the ability to control access to that asset, and also the ability to monetize that asset. So I kind of think of an NFT almost like your settings profile, except it's like a portable settings profile. It's not linked to a single app. It's like an account or a settings profile that is like owned by you, and therefore allows you to control access to that asset, and also to control the monetization of that asset as well. So it's like this portable account that allows you to control that asset that isn't tied to any single platform. So there's this idea of like data marketplaces. Maybe when you publish a data set or publish a model, maybe you like have an NFT for that represents your like IP ownership to that. And then you can do all these like really cool things. Like, what if we had provenance of all of these different data assets and model assets? And when a data set is used, maybe when a data set is trained on by a model, or when a data set is used for in-context learning, maybe by having this like ownership tracked somewhere, then you can like reward the owner of that data set when that data is used within a model, for example. Or maybe when a model builds on top of another model, you can like track that and maybe send some sort of like reward flow to the owners of that data set or the owners of that model. So this is like one of the interesting areas in crypto. Can you do it without crypto? Like maybe. And yeah, maybe you can. I just haven't seen it done anywhere, I guess. And so like, yeah, I think that's an interesting aspect.
So sort of like taking the idea of a public key server and making it way more distributed, right? And maybe richer in its capabilities.
Exactly.
Okay. Holmes, I'm sorry, I cut you off, Holmes. What did you want to say?
Oh yeah, I have a couple questions. So it sounds like, I mean, one of the really interesting things about this year has been how much my perspective changed on the inherent like power centralizing qualities of AI. I was very concerned about that at the beginning of the year, and then by the end of the year, it seemed like, or sorry, I would say about a year ago, it seemed like AI was fundamentally different from previous tech, and that it was power centralizing by default. And then this like upsurge of open source AI activity and the idea of running models locally is obviously so decentralizing by default. And I think you've touched on some of these ideas, but I go back to the worry that, like, for an end user, it's really, really hard to use anything other than the model that you know is the best, because you're always kind of delving into the unknown with it. So you never know if like a model that is not widely known to be the best is going to be good enough for your case. Like, once I have access to GPT-4, I never want to use GPT-3.5 because it just isn't as good most of the time in a way that's very palpable. And I never know when it's going to be good enough. So I can see where you might still use it in cases where performance is an issue or something, or scale or cost. But from an end user standpoint, they're always going to want to use the thing that is the best. And if what you're saying is that there's some like type of exposure to types of categories of thinking or categories of case that makes a model able to handle that case, it seems like there's a virtuous cycle where the more, the way Google is the best search engine because so many people use it and feed it information about what the best results are just by their clicks. It seems like there's a virtuous cycle that would be really hard to escape, where a dominant AI provider would sort of get that advantage. The way like Tesla seems to have that advantage in self-driving, with the flow of like its fleet being exposed to the most edge cases, therefore it has the best encapsulation of those cases, therefore it has the best product, therefore it has the biggest fleet. I know these ideas aren't that original, but do you see a way out of that? It seems like in decentralizing that, we need to find some type of decentralized infrastructure that can actually be the best in the general purpose way, and that can be the center of that virtuous cycle. And I don't know what the foundational technologies for doing that are, because it seems like, decentralized computation generally is still not like a well-known, not like a solved problem.
Yeah, it's a really good question. I'm encouraged like you, by the open source stuff that's coming out, but I still use GPT-4 every day because it's just the best. And especially compared to reasoning, like, you know, we see a lot of benchmarks where people are saying some models are coming close to GPT 3.5 or GPT-4. But there's like, in these reasoning benchmarks, GPT-4 is by far the best. Like maybe, let's say it's like a 90 score. And like then the next nearest open source model is like maybe less than 60 or something. So even though like on some of the benchmarks, it's like really good at, say, knowledge or like performing question and answering or something like that, in terms of reasoning ability, GPT-4 is still like streets ahead of everyone else. And yeah, no one is even close. And what I hope is that like now people realize where this reasoning ability comes from. It's only started coming out very recently. Now people are like really focusing on training these open source LLMs on code and all this sort of stuff. So hopefully it does catch up. It's possible that we're just in this like really weird phase where, you know, large language models are just like way ahead of open source. But by the time we get to like GPT 7 and 8, maybe the difference between GPT 7 and 8 is like smaller, and that gives like open source more time to catch up, I suppose. So yeah, it's really hard to know what's going to happen there. But I suspect that open source is going to catch up more with GPT. And that they're like, a lot of people think it's going to get commoditized, and that you know, it won't make as much of a difference in future as it does now. In terms of the like virtuous cycle of data, I think it's a really interesting question. And again, it's like there's so much going on here. It's a complex system and like really hard to predict the future. But like one of the things that I see is that like OpenAI trained on a bunch of data that wasn't even theirs, because they didn't have any data. They were a startup. And you know, a lot of the data providers are starting to realize this, and like Reddit has shut off access to their API. Twitter has shut off access to their API. These APIs are starting to become monetized. And so I think what we might see is that the data that is on the internet so far is kind of like open and accessible. But I think a lot of data providers from now on will make any data less accessible. So if OpenAI wanted to train a new model, I think they would have a much harder time of doing that, which is a disadvantage for them. That's OpenAI, I guess. Like then you can go to Google and say, you know, well, they just have so much data, they're always going to have access to it because people are always going to be using Google search. But then again, you know, people are using Google search less now, and people are starting to use language models more. So maybe like Google's data advantage will dwindle a little bit. And then there's all these other like effects at play. Like for example, if, you know, in context learning changes it so that you need less data to like personalize a model and stuff, maybe that like opens things up a bit for like independent providers, because it's like, yeah, sure, you still need like a ton of data to build the original model, but once that's built, then you can like kind of personalize on the fly much easier. And so yeah, I think there's just like so many different dynamics. It's really hard to predict. I think things are like naturally decentralizing. Like for example, the data layer, I see decentralizing quite a bit. We still have the issue of like compute. So another aspect that people are focusing a lot on in crypto is like, how do we decentralize the computing infrastructure? Because again, we just have this like monopoly where I think it's like 3 different cloud providers have maybe greater than 50% market share. And so I think like, I think AWS makes something like 60% margins, or maybe it's like 40% margins on their cloud expenses. It's like, it makes more money than all of the different areas of Amazon put together, which includes like the Amazon Marketplace, Amazon Prime, all these sorts of things. It's really like the biggest money maker for Amazon. And the reason that they can charge those really high prices is because, you know, it's basically a monopoly. And so there's like a bunch of really interesting projects that are trying to like decentralize this, lower the barrier to entry for compute providers, maybe like onboard, I don't know, people's personal GPUs and stuff. Maybe that's a little bit difficult because they're not like the H100s or whatever they're called. So yeah, I just see people trying to decentralize all of the different layers. Like I think the data layer is like starting to get decentralized. I think we might see like the compute layer start to get decentralized a bit more. And hopefully that means that these like big tech companies have less of a monopoly in the different areas, and that, you know, we can have a more diverse ecosystem of many different model providers and compute providers and stuff like that.
I'll give a piece of evidence to support what you're saying, which is that my fiance is not a computer scientist. She's a PhD student in physiology, but like basically a biostatistician, and she's using u.com as her search engine because it's better, right? And like I'm increasingly seeing people who are technical but not computer scientists who are just using LLM based tools instead of Google, whether it's you or other things, because it works better, and not because it's like, you know, they're nerds like us trying to use the hot new thing. And meanwhile, Google's been incredibly slow to to improve its service based off these advances. Bard is like kind of a shit show, and I think you're absolutely right. The small groups can move very quickly now with LLMs and make a product that can compete with something that probably costs billions of dollars to create.
For sure. And like another big, well, like this kind of goes against my arguments, I guess, but like I've seen people talk about, you know, having these super aggregators, like especially when it comes to agents. So like ChatGPT has put out a few demos where you can ask ChatGPT to like book a flight, and it goes and uses the Expedia API and gets the flights. And I think at the moment it still presents it back to the human to like confirm the flights, but you can imagine in future where you know, the human doesn't need to go to the Expedia website at all, and it all just happens through this like this ChatGPT app. And you can imagine that with like all of the different APIs. Maybe we just go to ChatGPT and ask it to do our shopping, and it goes to like a shopping site, and then we ask it to book flights, and it just goes to like the flight website itself. And all of a sudden, you have all of these users just going to a single app, which becomes a super app for integrating with all of these other apps. And that means that the user never needs to go to these other websites. How do they like sell ads? All these things that like completely gets disrupted. And I actually think what's going to happen here is that I think we're going to see a lot of APIs closing down. Like the data APIs are already starting to close with like Reddit and Twitter, but also like maybe Expedia will start shutting down their API for access, because like the AIs are going to be using it and like stealing all of the attention away from it. So we might be going to like a much more closed world where all of these APIs are kind of getting shut down. And I don't know what happens after that. It's going to be like really, really interesting dynamic.
You could also imagine some kind of punk hackery shit. Like it would be fun to train an LLM on all of the intellectual property of Springer, LNCS or whatever, or like Nature, and then don't put that property online, because we know what happens if you do that, but put the model online. And now you have a fascinating legal question about whether or not you can get in trouble for making available to the public something that has learned, you know, like essentially all of published academic knowledge.
Yeah, it's super interesting. And yeah, I think based on your question, Holmes, I think like ultimately what makes AI models powerful is the data. And the people who actually own this data aren't the big tech companies. And so hopefully that's where it needs to converge to, is that these big tech companies don't ultimately have all the power, because they ultimately don't have ownership over all of the data. And so if we can ever figure out how to organize in terms of our data and how to like monetize our data and stuff, that like really puts the hands in the power of like people, and like that's naturally decentralized. And so hopefully that's where it's like converging to in the long run. One more interesting snippet.
Yeah.
Oh, sorry, go ahead.
Oh yeah, no, I was also just going to say at some point it seems like there's some trove of like the data from physical reality that, you know, we get access to as learning agents our entire lives directly, natively. Like, and it seems like a lot of our reasoning abilities are based on. You know, when I say that, it just intuitively, it seems like a lot of our reasoning abilities are based on our faculty for understanding three-dimensional space and the physical world, and that we sort of like bootstrap things like language and but AI is funny because it doesn't really have access to any of that now. And if you unlocked access to that, it would be getting very, very high fidelity. Like the physical world never lies in a way. I mean, your interpretation of it can, but if you have access to some strong physical, like some textured representation of the physical world, you could be giving AI a lot of very powerful data about how things fit together on some level. That it intuitively seems like would be similar, maybe even more powerful than what it would get from reading through a bunch of examples of logical proofs or formal logical reasoning, or at least complementary. And then that
Totally.
all that data is accessible to anyone, anywhere, as long as they have the tools for capturing it and for kind of the word exploring it.
For sure. Yeah, like it's really surprising how much AI can learn just through our text data, because we learn through so many other avenues as well. And so, yeah, I think like once we start including some of this other data, it's probably going to blow our minds even more. I know that people are talking about like video on YouTube as the next source of data for language models, using things like Whisper and running it on all of YouTube. I heard some number about how much it's going to cost. It's going to cost like $1 billion to like run Whisper on all of YouTube, but then that gives you like a bunch more text data, and then like you can also like start to take the image data from that as well. That gives us a bit more than text, and then like the question is, what's after that? Like how, I don't know, is it going to be like sensors on your phone, or maybe like VR or something, as people actually move around the world and using that data to train language models? I think, yeah, hopefully that's going to be more decentralized, because anything that happens on our device is going to hopefully be more decentralized compared to like what we put on the web. So yeah, I hope that works too. And one of the things I was going to mention, which I think is like an interesting thought experiment, is so it's related to like copyright. And copyright is this really weird thing where people often say that we should preserve copyright for artists, for example. And I actually I agree with that. I think it's like important to like reward artists for when an AI is used to create some work that is like based on their existing work or whatever. But it's actually a really complex question, because who owns most of the copyright in the world? It's not just like small independent artists, but it's actually like these big corporations or whatever. And so the thought experiment that I was doing was, when I join an organization, I sign away all of the rights to my IP that I create when I'm a member of that organization. So if I like create an invention or a patent or something, the organization owns that. And so that means that they own that copyright of the stuff that I create, whether it's like code. I think in Europe, like if you write an email, it's actually protected under GDPR. So the company that I work for doesn't own the emails that I write. But and I'm not sure what it is in the US, but just imagine that you work for a company for like 5 years. You write a bunch of code for them, they own that. Let's say you write a bunch of emails for them and documents, they own all of that text. Maybe they can even like screen record everything that you do as you take like action in the browser. And then you work for them for like 5 years, and then they basically take all that data and train this like this language model on all of your text data, all of your code data, all of your browsing data. And then they can basically like simulate you writing code or writing emails, or maybe like even browsing the web and stuff. And then they can like fire you, and because they have no need for you anymore, because they've kind of simulated you, maybe the language model kind of remains fixed or whatever. But yeah, I just think this is an interesting thought experiment that kind of shows issues with the current setup for copyright that we have, and the importance that we keep ownership of our data ourselves, because whatever we don't keep ownership of is ultimately going to be used to like automate the tasks that you do and reduce the value of that. So hopefully it's not the same like once we have all this sensor data and stuff as well. Imagine if people really did have all of access to all of the data that you create on a daily basis. They could basically create this clone of you and use that to kind of generate value, and then there's no more need for you anymore, I guess.
Richard, we're almost out of time, so I want to give you an opportunity to pitch Algovera, the micro grants, whatever it is that you're excited about that maybe either people who are here right now or again, people who watch on YouTube later on might want to follow up about.
Yeah, that's great. I guess we didn't talk about Algovera too much, but yeah, what we're doing is like creating this platform that allows people to create different LLM apps, which could be things like LLM workflows, LLM assistants, LLM agents, and just making it easier to do that than using Python or JavaScript or something like that. So we like kind of lean towards no code. So you can create a personal assistant on your own at the moment just public data sources, but eventually we want to do it at the edge as well, so that you're not uploading to OpenAI. It's just that open source models aren't there yet. But you can create these assistants for yourself. You can create agents, all these sorts of things. So that's what our product is. And then we're doing a lot of like R&D. We do a lot of contract work for different projects, trying to like really build like different frameworks for LLMs and that sort of stuff. So like we're thinking of building a new version of LangChain that is that has some advantages and stuff like that. And also like we do a bunch of events as well. So we actually have a Decentralized AI hackathon coming up in Paris on the 18th and 19th of July. I guess everyone here is based in the US, so it's probably quite a long way. But we're hoping to hold more of these, and we've got some really good sponsors like Hugging Face and Stability AI and Llama Index, as well as some like crypto projects around, say, using NFTs for assets and stuff, and just like really hoping that some really interesting approaches to decentralization of AI come out of that. And so, yeah, keep an eye on that. Hopefully we're going to have some like remote hackathons in future as well. And we're really just exploring all of these different technologies that can be used to decentralize AI. And maybe it won't work, who knows, but we're going to try.
Cool. Richard, thank you so much for joining us. This was a ton of fun. We appreciate your time. And hopefully you get some emails or leads or people joining the Discord or whatever in the future from this.
Awesome. Really enjoyed it. Thanks. And yeah, everyone just feel free to reach out. You can find me online.
Awesome. Thanks
everyone.
Richard. Bye.
Thanks for the discussion.
Cheers.
Bye-bye.